Okay, so recording has started now. So let's continue where we left off. So let me open Eclipse and try to do this as fast as possible. Because I think you guys have a practice session around, I don't know, 1 or 2, somewhere there. So I need to be quick. So we're still doing the regular expression for one of them, right? Where did I put that? Yeah. So this was the regular expression for the firework display, right? So what I'm going to do is I'm going to copy this and then go back to I hate regex. And then I'm going to paste that regular expression again here. And then what I'm going to do, right? If you want to represent a tab, you can say one or more spaces, which is the \s plus. That's another way, or you can just say \t. But then since they specifically told you that it's a tab, I think it's advisable to just say \t. So that's the only thing that I'm going to change here. I'm just going to put in a \t, and you see that it still matches. There's my input. It's still matching the input. Then I'm going to copy it again, and then go back to Notepad, and then change it. Then I'm gonna go to my practical. Then we're gonna see I think it's pyrotechnician. So let's see what's the other regular expression we need to come up with. Oh, there's 3. So yeah, there's quite a lot of regular expressions to come up with. We have the pyrotechnician and we have the fireworks. Remember, this is firework display. Then this is just fireworks. So meaning the firework class. So let's start with the pyrotechnician. So I'm gonna copy this. I'm doing it this way because I want to be able to copy and paste my regular expressions into my code once I start coding, which makes my work easier. So let's scroll down to the information about pyrotechnician. So pyrotechnician full names are formatted as follows. So you have Y, and then you have those X's, and then you have a hyphen, and then you have Y again, then you have these X's, where Y is any capital letter, right? Any capital letter. So I'm going to go to my regular expression, then delete this, and then delete this example, and then come up with the new regular expression. They said any uppercase letter, so that means A through Z like this, any, right? And it's exactly 1. They didn't say 2 or no, they just said any uppercase letter. When they say any capital letter, they say letter as a singular, not letters. So you know that it's exactly 1. And then X, where X is any number of lower cases, any number. You see the important thing, any number. So there's many ways you can approach it, but I assume that the person's full name, there's no way if a person has a full name and it's only 1 letter. So it has to be at least 1. So it's 1 or more. So 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 I'm gonna have some. Can you please mute? Whoever is not muted, can you please mute? So you're gonna have this. This is the capital letter followed by any number of small letters. So I'm gonna put in A through Z like this. And there's no other way of writing this in short, right? You have to write it like this in full because of the regular expression you must come up with. And we want 1 or more letters, right? So plus, meaning 1 or more small letters. They didn't give us an exact number, so we just assume it's to infinity. So what I'm going to do, I'm going to try to look for it in this example. Yeah, it's this one. So I'm going to use John Doe. So it's this line over here. This represents the pyrotechnician. So I'm going to go back here. So under hide matches, under this part here, you put in the example that you want the regular expression to try to match. So I'm going to paste that example there. So far so good, but then we're still not done. It's still not complete yet. So I'm going to go back to my practical. So after this first word, right? So far I've represented 1 word, which is just it starts with a capital letter and then followed by any number of small letters. After that, it's followed by a hyphen. or that symbol that looks like a -1. That looks like a minus sign. Then you're gonna say minus like this. But you see that the regular expression doesn't look neat if you just write it like this. You can write it like this to make it a bit easy to read. Or you could, this is also applicable, right? You can also put round brackets. So that's why your lecturers, they can say you copy it because not everyone thinks the same. There's a lot of ways to approach this problem. You can, this is my way, this is the way I would have written the regular expression. Maybe you came up with a different way. That's just up to you. Don't cram my formula because you're cramming my formula, it means you're gonna fail because the practical always changes. So followed by another capital letter. So I'm gonna say capital A, letters A through Z, and it's only one, right? So that I'm not gonna put a quantifier next to it. Then I go back and then I see all these X's, which is one or more small letters. So I'm again going to say A through Z, small letters, one or more plus. And you see that at the bottom here, it's starting to match, right? Now it is matched the full person's name, the person's full name. What does this space represent? If you go back to your practical at the top there, that's how you need to read everything. Data is separated using tabs. So everywhere where there's a space, they're telling you that know that that's a tab, meaning \T. That's how you represent a tab in coding or even in regular expressions. So I'm going to put a \T to say that after this person's full name, a tab comes after. Then let's look at the number, right? The phone number, PT phone number. So I'm going to scroll down and go to the number. Yeah. So pyrotechnician phone numbers must start and end. You see, they're highlighting in the end here. And it must end with a digit that is not 0. Yeah, I know the answer, but you have to really think about it. They say it starts and ends with a digit that is not a 0. So the phone number is in this format, right? They're telling you the format, meaning that we start with 3 digits, a hyphen, 3 digits, a hyphen, and then 4 digits. But then they say the last digit, which is this X here, you see this X, the last X, this digit over here, it's any number that's not 0, meaning 1 to 9, which means excluding 0. So there's many ways you can also approach this, but I'm going to show you the way I'm going to approach it. So I'm going to say, and you see that they say separate digits using a hyphen. So the formula is 334. So 3 hyphen 3 hyphen 4. So these 3 digits, they can be any digits, including 0. So that means I can just say 0 through 9. Remember the square brackets, they are inclusive. So it means including 0. I can include 0. But then it has to be exactly 3. So I'm going to choose curly braces because I want to specify an exact number. That's how you can specify an exact number. You use curly braces and then you pass exactly one number within the curly brace. So I want exactly 3 digits. So I'm going to put a 3 there. And then you see it matched the first 3, followed by a hyphen. And my hyphen, I'm going to put it inside square brackets to make my regular expression readable and easy to understand. I don't want someone to think it's a minus. And then followed by exactly 3 digits again. So 0 through 9, exactly 3 digits. And then you see it matched, right? And then after the 3 digits, I need a hyphen again. So I need to put in a hyphen. And then you see it matched. Then now this is the tricky part, the last part. I can't say all the 4 digits. It should be 0 through 9. No, it's only the first 3 digits, which can be any number from 0 through 9 to 9. And then the last digit, it's only from 1 to 9. It means that it excludes 0. So the way I'm going to write the regular expression for this, I'm going to say the first 3 digits, it's within 0 and 9. So 0 through 9, the first, it has to be exactly 3 digits, right? Those exact 3 digits can be any number, 0 to 9. It includes 0 and it includes 9. Then you see that it has matched everything except the last digit. So I need to write a formula for the last digit. What did they say in the practical? They say the last digit, and it must end with a digit that is not a 0. So meaning the last digit should be from 1 through 9, not from 0 through 9. So I need to say 1, 2, 9. And it's only one digit left, right? So I don't have to put in a quantifier. I leave it as it is. And then there you go. There's the match, right? To show you that it does work, let me change the last digit to 0, right? Okay, it should match. Oh, they said excluding 0. So yeah, if I put 0, you see that it doesn't match because the last digit, I say its range, it starts from 1 up to 9, which means it excludes 0, which means I've followed the instruction. So it can be any number 1 to 9. So you see it's matching. So I know that my regular expression is correct. So I copy it. I go to the side, I click copy, and then there should be a pop-up message here. You see this message here to show you that it copied the regular expression. Then I go back to my code or notepad, wherever you're currently saving it. Then paste it there. So you see I'm almost there, right? We are moving, there's progress. So now the last thing is the fireworks, right? So the fireworks. So I'm gonna open this and then I copy my line that I'm trying to match. Then go back to I hate regex, paste that example that I'm trying to match, and then delete all of this, right? Delete everything because now we're dealing with a different regular expression. So I'm gonna go down to the explanations, right? So they say the firework ID, it starts with FW, followed by additional 6 digits, right? 6 additional digits. So they gave you an exact number. So you know how to represent an exact number. So it's going to be FD and then followed by 6 digits. So this regular expression, I'm going to be consistent, right? So let me show you, let me check my regular expression. Yeah, I was supposed to be consistent. You could have used, instead of \d, you could have said 0 through 9. That's fine. So it's fine. I'll just mix. Like I said, the regular expressions, there's many ways to write them. So let me use \d. So it's any digit. Remember, \d just means 0 through 9. It's a shortcut for 0 through 9. So I'm going to say \d, and they said exactly 6 digits. So I'm going to quantify it and put 6 in there to say that it's exactly 6 digits, not FD. What am I saying? It's FW and exactly 6 digit. And then you see it's already starting to match, right? And then they told you that each and every single thing in the file is separated with tabs. So you see an empty space, just assume that's a tab. So \T. And then you see it matched that tab. Then what's the next thing after the firework ID? So the firework names, they can be any length using uppercase and lowercase letters in any position. And it can contain spaces between the words. So for example, sky, blossom, which just means this. So it means any letters from A through Z, uppercase letter, or small letters, they're also applicable, or just a space. So it includes one of these things, uppercase letters from A to Z, small letters from A to Z, or a space. And then one or more, because they didn't give us an exact number or a minimum. Like let's say maybe they said at least 2 to infinity or 2 or more. If they'd said it in that way, then we would have write it in a different way. But they said it can be any length. But we expect it to be at least 1, right? Because it can't be empty. Because if it's empty, that means it's not gonna match. So it can't be empty. So it has to be at least 1. So 1 to infinity or 1 or more. So I'm gonna use the plus. Then I have a space after Y, and we were told that the spaces represents a tab, so \T. Then how do you represent a decimal or a double? It's simple. What's in front of the dot? It's Y. It's a single digit. What's behind the dot? It's a single digit. What's in between the values? It's a dot. So that's what you call a double. So I'd have to say \D, and I have to say that it's exactly okay. I think let's read the question. Let's look at the question because maybe it can be any number. So let's see. So the firework fuse length, right, must be any value greater than 0. So you see why it was important for me to read. As well as any decimal value that is greater than 0. So what they mean, right? So they say it can be any value greater than 0. So what they mean is that, or it can be any value that is greater than 0. So that means the length should be at least 0.1. That's what it means. If it's 0.0, that's just 0, which would be incorrect because they said that the length should be at least. Can you please mute? So it can be of any length, right? So if you, but then that length should be greater than 0. So by definition, right, mathematically, right? So this will be the firework regular expression. Mathematically, right, 0.0 is just 0. So if they say it needs to be at least greater than 0, then that means the minimum should be 0.1. So that means before the dot, right? If I zoom in a bit, if you look at the dot, before the dot, it can be a 0. So that means before the dot, it's numbers from 0 through 9. So that's fine. We don't have a problem there. So that means I can come here and say, okay, I just say \d. They didn't give us an exact number of how many digits, right? So let me go back here. They didn't tell you that how many digits will be there before the comma or after the comma. And you see that here it's 5.2. So that means it can be of any length, but minimum is 1 because we need to have at least 0.1. So if you look at 0.1, you see that it's at least 1 digit after the dot, and before the dot, it's also at least 1 digit. So that means it can be any length of the digits, but it's at least 1. So I'm going to put a plus, followed by the dot. So dot followed by the dot, and then followed by, I cannot use \d again here. Why? Why not? Because \d, it means from 0 to 9, which is not what I want. I want to exclude 0 because the question said that it should be at least greater than 0, meaning the number after the dot should be at least 1. So that means I'm going to say from 1 to 9, and at least one or more of those digits. So I'm going to put the plus there. Then there's this space again here. Then we know, oh, that's a tab, because we were told in the question paper that anywhere where there's a space, it's separated by tabs. So \t. Then we have this yellow, which is a color. And you see that it's a constant, right? It's an enum, right? So to represent something in regular expressions as one of, right? Meaning one of these things, this is how you represent it. So let's say my question says that, let's say I was given a question that says that the answer can be y, or it can be n for no. Y for yes, n for no. So my regular expression would just be simply like this. You have to say y, and then you put the pipe. The pipe means or. So pipe n. But then just put what is round brackets to make to usually put it in round brackets for it to be easy to read. So this would mean y or no. Just translates to that. So if we have, for example, a question like this, whereby it can be yellow, green, etc. So this means that I can write it like this and say yellow, pipe meaning or, it's yellow or green. If there's more values, right, you can keep saying or, and so forth. That's how you write it in regular expressions. So I'm gonna go back to my question and see what are the colors. Yeah, there's a lot of colors. It's fine. I'll copy and paste them one by one. I don't have time to be typing them. So after this, they can be any of this color. They can be any of this color. Which are the colors? So I need to list them. So remember, I told you, you need to put it inside round brackets. So it can be red, or can be orange. Um, so let me do this. Let me try to make speed up things. Let me do this. Paste it here. Right. So I'm gonna have this. So this will be or orange, or green, or blue, or yellow, or magenta, or white, or CN. So this will be the list of the colors, can be any of them. So this just means, remember I told you, this just means red or orange or green and so forth. So every time you see this pipe here, it just means or. So delete that, go back to my regular expression, remove this and then paste. So you see your regular expression becomes very long. It can't even fit in one line, so they have to add it on a new line. So this will be the full regular expression. So now I'm going to copy that regular expression since I'm now done. So I have all of my regular expressions ready now. So there they are. So I need to leave them here and then go to my code and start working. So remember what I told you. Another word for a regular expression, we call it a pattern. So since that's called a pattern, inside Java, there's a class called pattern, which stores our patterns or our regular expressions. You see how easy that is to understand? So I'm going to write this and say these are my instance variables, right? And then remember Java doc, comments have marks. So I'm going to create my instance variables, right? So I'm going to have private. Since my patterns are not going to change, why would they change? Because they're fixed. You see that they're fixed. They're not going to change. So technically, it's like I'm creating constants. So that's why I'm going to say private final. Remember, the final keyword is the same as writing constant C++. So you're going to write final in Java to say this is the final. It's the final thing. You can't update it any further. Remember, variables, they can be updated. So when you put final in Java, it just means this is the final value. So private, what is the data type? What's the data type we use? Remember what I told you, these are patterns or regular expressions. In Java, they call them patterns. So I'm going to use the pattern class like this, and then I'm going to look at my patterns. I have a pattern for firework display. I have a pattern for pyrotechnician. I have a pattern for firework. So I'm going to name them after the thing that the patterns that it represents. So I have a pattern for firework display pattern, right? That's what I'm gonna name it. Okay, it's a bit too long, right? It's a bit too long for my liking. So I'm gonna call it F display pattern. Should I call it yeah, let me call it F display pattern. Then I'm gonna hover or go over this red line, and then you're gonna see that it's gonna show me import. I want to import it, and it's part of java.u2.regex. Regex, remember, stands for regular expressions. So I'm gonna import, and then there's my import here. So now we can continue. And remember with regular expressions, right? Or with constants, I mean, you have to initialize them upon creation. You don't initialize them later because remember they're constants. They have one final value. So how do you initialize a pattern in Java? You call a static method called compile, which is part of the pattern class. So how do you call a static method? You start by writing the name of the class, followed by a dot, and followed by the method that's static. So that's why I'm using the name of the class pattern, because I'm calling a static method. So dot compile, and then I put in it expects a regular expression. So the regular expression, you have to pass it as a string because the compile function expects you to pass a string. As you can see the documentation, you see it expects a string regex, meaning the string representation of your regular expression that you are creating. So this is what firework display. So I'm gonna choose come here and just copy all of this, which is just straightforward. You see that when you have your regular expressions, it's easy, right? It's straightforward. So I'm gonna paste my regular expression. There it is. And then there's the whole regular expression, right? Make sure you put it within double quotes because the compile method expects a string. The warning, it means that I haven't used it. It says that it's not used. That's fine. We're still coding. We'll get to the use later. Then I create the next pattern. So pattern, we have a technician pattern, right? So tech pattern. I'm just going to call it tech pattern because I don't want to have words that are too long. So dot compile and then semicolon. Within the compile method, I pass in a string. So I go to my regular expression that I made. I'm going to copy all of it for the pyrotechnician, and then I'm going to paste it in there. So paste. So there's my regular expression. So you see how easy it is once you have the regular expression. Just be copying and pasting. So private final pattern. The last one is firework pattern, right? So firework pattern is equals to pattern dot compile to compile that pattern. And then it expects a string as usual. And then I'm going to look for my firework pattern. So there it is. I'm going to copy all of it. And then go back here, paste, right? So there's my firework pattern. So I'm done with my patterns, right? The declaring the patterns. So now I'm going to go to my question and create that method that I was told to create. So let's look at the method. So FMB, right, requires all development is correctly and accurately modeled, and therefore requires you to complete a UML class diagram for all classes in your solution. Yeah, that's a you problem. You would have to go create the class diagrams. It's not a me problem. Me, I have to just do the code because you guys would you actually it's last semester when you're doing ComSci 1B. So you can't say you forgot how to do UML. It was last semester. I don't know why guys don't mute. Hey, it's really starting to get on my nerves. I'm a very impatient man. So let's create a display. Says create a display file handler class inside the package. We already have the package, so that's sorted. So I'm going to copy this class name, right? So that I don't have to think about it and the capitalization and everything. And then, yeah. So, oh, there's the class. Oh, we created the class, right? So what I need is the display method. So it's called read display. So just copy it. So the class must have a read display method, which takes a file name as a parameter. File name, right? It means the name of the file. So in what data type would you use to store the name of a file? It's obviously a string. So they expect you to understand that. So I'm going to go here to my class and then I'm going to say public, right? So public to make my life easier, right? You can also do that for you, that's fine. But to make my life easier, I'm going to say public and make the method static. I don't want to be creating an instance because if you look at the practical, did they talk about the constructor? Nope. So your constructor doesn't matter here. What matters is does the code work? So I don't have to be creating an instance. So I'm going to make it a static method. So public static, and it's a method that doesn't return anything. They didn't specify that it should return something. Or it does return. So let's see. So it returns the firework display. Yeah. So it actually does return something. So it returns a firework display. So I'm going to copy this static firework display. Remember the syntax for a static method. You start by the access modifier, whether that's public or private, followed by static, followed by the data type, followed by the name of function, and the parameters within the round brackets, and then your curly braces. So I'm still following the right syntax for declaring a function. So what's the name of the function? They said it should be called read display, right? And it should take in the file name. So it's string file name, because that's the only data type you can use to store the name of a file. Then I'm going to import my firework display. Remember, this import won't show if you didn't do what we talked about in yesterday's tutorial, that when you go to lib, your jar file, you need to click it to select it, then right click, then go to build path and click add to build path. If you don't add it to build path, your code won't compile, which means you won't submit, which is a 0. So make sure you follow the instructions. So I'm going to go over this and then import, and then boom, right? Problem solved. Then since I know this class is going to return a firework display, I'll just create a firework display value. What is this? Display instance, right? So I'm going to call this obj display. And then I know at the end of the day, this function should return obj display. So I just want that so that it removes all the errors, right? So okay, still showing the errors. That's fine. So I'm gonna put Java doc. So let me put Java doc. To put Java doc, you just write 1/ and 2 asterisks, and then press enter. That's how you do Java doc. So let me show you. / 2 asterisks, and then you just press enter on your keyboard, and then boom. The rest it does it for you. But make sure you declare the function and pass all the parameters first. So file name, I'm just gonna explain. This is the name of the file. You might not understand why is JavaDoc important. I think I'll show you once I'm done solving. I'll run the batch file to generate the JavaDoc so that you see that all of these comments, everything that I'm writing, it shows on the JavaDoc. So it returns a firework display instance, right? So let's start. Let's see what we're going to do. So let's go to our file. So you need to read through each line of the file and test for validity. If it's not valid, an error message should be printed on the error to the error output stream. So that means you need to read every line, check if that line matches with your pattern. That's the important thing. It should match with your pattern. So you see the word, the terminology that I'm using, right? I'm using the terminology of matching. So in order to match something, we need a matchmaker, right? The person who's going to be matching the things, a matchmaker. So for example, let's say you don't have a date for Valentine's. Then they tell you all students should come to the parking lot. We're gonna do a matchmaking thing, right? So the person who's gonna be doing the matchmaking, I guess, is gonna see if you guys correspond. Do you guys match, right? So since there's someone who's going to be doing a matchmaking, so we need a matchmaker. That's why inside Java there's a class called matcher. So we create a matcher instance because it matches. It is trying to match the pattern with the line with the lines in the file. So I'm gonna create a match and call this f display matcher, right? And then I need to import. So let me import. Make sure it's part of java.util.regex. Don't import any other spiritual things. So I'm gonna import, and then I'm gonna say create a different matcher. So the way it works, right? The way it works, even though in the real world it might not work that way. The way it works, you can imagine that when you go to that parking lot and you're looking for a partner and they're doing the matchmaking, imagine that if they had enough matchmakers, each student would have their own matchmaker. So that's how Java wants you to do it. So that's why for each pattern, I'm gonna have its own matcher instance. So that's the way you should do it in Java. So tech pattern, there's no other way of doing it. No, tech matcher, and then I need another matcher for what is this? Firework. So firework matcher. So these matcher instances, they'll help us match our patterns with the lines in the file. Why are we doing that? We're doing that because when you go through the file, right? When you go through the file, we're gonna try to match line by line. We're gonna check this line. Does it match with our pattern? Then you know, oh, this is a firework display. Then I store this information inside the variables for a firework display. Then I see, oh, this one is a pyrotechnician because it matched, right? Then I store it into a pyrotechnician instance. So that's the main goal. We need to make sure that things match. So I'm going to go back here to my code and then let's do the file handling, right? So with file handling, in this practical, you're only doing reading. So so that means I only have to explain reading. So why do we need a lot of things in Java? Why couldn't you just create a string for a file? Some people think that to create a file, you just say string file and then you store the file name. Let's say clean one. .txt. And then that's done, right? And then it finds the file. Well, this is not Java. In the language of Java, it doesn't know that this is a file. It thinks this is a string, of which it is a string, so it's not a file. So to tell Java that, listen, what I'm writing now or what I'm creating now is a file instance, I have to use what we call the file class. So you have to create a new file instance. So we have a file class. So one of its two purposes, right? It's number one, to help Java not confuse and think this is a string, but when it's actually a file. So we're helping Java to know that, listen, Java, this is actually a file. It's not a string. That's the first purpose. And then the second purpose is for what we call um, it's low level stuff. It's like dependent on the operating system. So I've used what we call Linux, right? So I even have, let me show you, what is that thing called again? Is it MSys? Oh, okay, I removed it. But in Linux, you have, it starts at the home directory. And I want you to notice very different, how different it is. So we have the home directory, then you have maybe users, something like that. And then your name, let's say, um, let's say Jack, right? That's your name. Then you can have things like your documents, folder, and so on. In Windows, it has a different philosophy. So it has to say C drive. It has what we call a C drive. And on Windows, it uses opposite, which is backslashes. So backslashes users, backslashes Jack, backslashes documents, right? So on anything like on a Unix operating system or Linux operating system, it's like this. It starts at the home directory. That's the root directory. And it uses forward slashes. The C drive, in Windows, it uses what we call the C drive, and it has a backslash. So you see that it's now, if you don't have something to help you distinguish, you can have problems because that means you must write code twice. One code for, not even twice, three times. One code for or a MacBook, one code for Linux, one code for Windows. So you have to write three times because those operating systems, they have different philosophies. So this file class, it helps us avoid having to know those differences. So with the file class, we just specify the name of the file, or there's something called a relative path. So a relative path is just sort of like a short location. It's like a sort of like a shortcut. We don't specify the full directions. We just give you like a hint or a short, sort of like a shortcut. I want you to view it in that way. So that's what you specify in Java. And then what Java does, it's gonna append the full path for you. It's gonna depending on the operating system because you can see the differences. The one uses forward slash, one uses backslash. How will I know? I would have to distinguish, which is too much time and too much thinking and code, and it's unnecessary. So what Java does, right? You only specify a relative path. So let me make an example. Let's say you tell Java that, oh no, just go to documents, right? Just go to documents. And then within documents, you're gonna find a folder named, or my practical is named, it is my initials, blah, blah, blah. Or let's say it's called P03, right? So that's where you'll find my practical, right? So just go to documents. Within documents, you're gonna find my practical, which is which is called P03. Then what the file class does is gonna check what operating system you're using. Then it prepends, not append. Append is to add at the end. To add before, we call that prepend. It prepends this information in front depending on which operating system you're using. So if you're using a Linux or MacBook, it's going to append this part over here. So it's going to take your relative path. You see, this is relative. It's not the full location. Then it appends, then it has one full thing like this. And if it sees that you use a backslash or whatever, it's going to convert the slashes into the for the right operating system. So the file class helps us to do all of those things. So I hope that's enough explanation to understand why the file class is important. So let's tell Java to create a file that, let's say, let me phrase it this way. Tell Java that the following represents a file, not a string, not a string. so that it doesn't think this is a string. I want Java to treat it as a file because it's actually a file. So to create a file, you use the file class. I mean, duh, it's a file. So you're going to use a file class. So file, I'm going to call it file, just file, small letter file, is equals to new file. Because remember, it's a class. You need to instantiate it or to create it. And then you import it, which is java.io. Then here, there's many things you can pass. You can pass a URI, right, which is uniform resource, uniform resource indicator, something like that, which is a URL. Basically, a URL is like this. You see this? If I copy this and then I go to Notepad++, this would be a URL. You see, it starts with HTTPS or HTTP. So this would be a URL. So programming is really advanced. You can actually read something that's online using the file class. So yeah, you can experiment on that. Or you can just pass a string. You see, we want this one where I pass in a string, which is the string which represents the name of a file. So I want to pass the file name here, right? I pass the file name and then done. So Java now knows that this object or this instance called file in small letters. It means that I'm referring to a file. And then there's many methods you can call for that file. Like, for example, you can get the relative path, then get the absolute path. So remember, I was talking about relative. This will be a relative path because it doesn't show the full location. If it's in full like this, right? If it's in full like this is what we call the absolute path. If you're only specifying one folder, if what you are specifying doesn't start from the C drive, that's what we call a relative path. If it starts from the C drive or from the root directory, we call that an absolute path. So notice those differences. Although you notice that you should need to make sure you keep track of that. So we have a new file. So now how will we read the file? You still remember our friend called scanner. That's what we're going to use. So scanner is very useful because you can scan different types of things. You can scan files, you can scan your input that you type on the terminal. There's different things you can scan with the scan. So I'm going to create scan and call it scan or just scanner. This goes to new scanner, right? And then I'm going to import java.util. And then instead of passing here system.in, I don't want to read my input stream. No, I'm not getting input from the user. The input is no longer from the user, it's from the file. So make sure you don't pass file name here. That's not going to work because what that means, it means you're just passing the name of the file. So it literally means you're doing this. Clean one.txt. And what the scanner will do will only scan this actual string, which becomes very incorrect. So that's why we need a file class to help us tell Java that, no, I'm referring to a file. Then I'm going to pass the file instance in there. You see, there's the file instance. This can throw exceptions, right? For example, like file not found. For example, the file does not exist. The scanner can not scan a file that does not exist. So you need to handle that exception. So if it shows you an error like this and it forces you to, yeah, I was right. It's called file not found exception. If it shows you an error like this, what it means that this is called a checked exception. A checked exception is an exception that Java forces you to handle. An unchecked exception is an exception whereby it will let you slide. It will let you do your thing, but if things go wrong, that's a you problem. So there's those two types of exceptions. So there's two options you can do. You can say add throws exception to just say this function throws that exception. But I want to handle it. I'm just going to say surround with try catch. So click there and then boom, it surrounds it with a try catch. Then I don't want to print the stack trace, right? You see this stack trace, right? It means print what's inside the stack. So remember, what is this code? When you have things like functions and stuff, it uses what we call a stack. That very same stack you were taught in ComSci 1B, that's what it uses. So when you call the print stack method, right, it means print what was there in the stack, which is this is an example. So it's gonna look like this. Does that actually make sense? No, it doesn't, right? So what you can do is you can just simply say sys error, then press enter, and then you output that file was not found, or file does not exist. I think that's a better exception, right? And then don't forget to what? Close your scanner. So I'm going to put a finally block here. Remember, finally block, it executes regardless of whether there was an exception or not. So regardless of whatever what happens, I'm going to need to close the scan. But I'm going to show you something very important that you need to understand. It's going to show me an error now. So scanner.close. You see that it doesn't know what scanner is because there's this thing called scope. I've declared my scanner within these curly braces here. So the scanner variable only exists within here. So how do I fix that? I declare it first outside the try catch like this, and then just initialize it to null, right? To nothing. And then within my try block, I instantiate the scanner. But then before I close, right, this may be a problem. You see, this part over here closing may be a problem. Why? Because what if it throws an exception? That means scanner is null. So that means I'm trying to do this. I'm trying to say null to close. You can't close null. That makes no sense. So you'd have to do it this way. You have to check if scanner is not null first. So if my scanner is not null, meaning that it has something, then I can close it. Or else if it has nothing, it's fine. Leave it as null because at the end of the day, it's still null. So this is how you have to write it. And that'll be the correct way. Then after I've created my scanner here, especially in try block, after this has passed or it went through, then now I need to scan my file, right? Basically go through my file, go through my file. How do you do that? Remember, if you look at the file that we have, let me open a different one. Let me open partial. Okay, this is too small. Let me open. Okay, it seems like they don't have a lot of examples in the files. So yeah, we're just gonna have to use these 3 lines. So it's fine. So you see with the scanner, right? Remember, you see that these are multiple lines. You see, there's line by line. So what I can do, I can ask my scanner a question while there's still a line to read, then continue scanning. So how do I do that in code? I have to do a while loop and say while scanner dot has next line. So basically there's a next line to read. While there's a next line to read, then read the line. So I would have to read the line. And then it goes back, it goes here, and then it goes back up. And then it asks the question, is there another line to read? If yes, then it executes what's inside the loop. So how do we read the line? Remember, there's those next methods. There's next int, next double, next float, next short, next line. So there's those next methods that we use to read things to read things using the scan. So I want to read the line. So that line that I read is going to be of type string, right? So I need to store that string, declare the string. So I'm reading a line from my file. So scanner dot next line. I want the whole line, right? I want the whole line. If you use the next method, you see the next method, right? It has limitations. Let me show you. The next method is a problem. There's limitations. With the next method, do you know what it does? It's going to read this next string, which is this, and stops there. Then it reads the next thing, which is a tab. Or it might skip. It might skip. Yeah, I think it should skip it. And then read the next string, which is this. And then this is also white space character. Then it reads only this. Then it skips this and then only reads this. So you see that it becomes wrong if you do it in that way. So I have to read line by line. So the whole line, not, I don't have, I don't know, I shouldn't use the next method. Then after I've read the line, remember what I talked about when we're talking about regular expressions, that if you want the regular expression to be strict, you can put in a dollar sign at the end there and a that cap there to say this is like this is where the line starts and this is where the line ends. So that means if there's spaces like this on both ends, then it won't match. So there's a function inside Java that you can use to trim, meaning to remove on both ends those white space characters. So I want to demonstrate that function. So I'm going to change my regular expressions a bit. So I'm gonna put here that to make it strict, and then a dollar sign there, and then put in that cap again, and then put in dollar sign there, and then put in dollar sign there, and then put in that cap here, right? And then now I know my patterns are going to be strict. So I also need to trim and make sure that everything is I need to make sure my edges are on point for the girls out there. I agree, you girls will be like, I need to make sure my edges are on point, and it's the same thing here that we're trying to achieve. Just need to make sure the edges are on point. Make sure the edges are on point so that when your friends see you, they'll be like, you go, girl, or whatever, how you girls cheer on each other, right? It's just a funny joke. It doesn't, but you get the point. So let's trim the edges. After trimming, I'm gonna store them in the exact same variable because I don't want to waste time redeclaring. No, that's not necessary. I'll just say use line and then take that line and then you call the trim method to trim the edges. The line that I've read, I've made sure there's no white space characters before or after the line. So that's fine. Then now I need to create or instantiate my matches, right? Remember, we're trying to match. So how do you instantiate your matches? So you're going to choose each matcher by one. So I'm going to say f display pattern. No, not pattern, matcher. F display matcher is equals to new. Okay, you don't have to say new. You can do it this way. To initialize them, you can do it this way. And the reason why I'm initializing it inside the while loop, you'll understand why. Because the matcher needs to match each line. So that's why that's why I initialize them within the while loop after I've read from the file. So what do I want the line to match with? With my pattern. Remember, this is a firework display matcher. So I need to use the firework display matcher. The firework display pattern, I mean. So f display pattern dot why is it not picking it up? Did I forget something? Is that what it's called? F display pattern. Yeah, that's fine. Yeah, I don't know why it's doing that. Create a class cannot be resolved to a type. Why is it doing this now? Let me copy it. And then f display pattern dot what am I missing? Oh yeah, I see. Hey, you need to be very careful in programming. I just almost forgot a small detail. Remember, in my solution, right? Since I'm making the method static, with anything that's static, you can only call other things that are static. That's actually how it works. So if you look at my constants, right, they're not static. So for me, you might not do that, that's fine. But for me, I have to make them static. So static. Oh, shocked why it's not picking up. And then copy, and then go inside here, and then now it's going to work. So firework display pattern dot matcher, right? I call the matcher function, which is going to match my pattern against what? The line that I've read from the file. So I need to do this two more times, and then I'm gonna have what's the other one? The tech matcher, which is gonna use the tech pattern dot matcher, which matches with that, checks if it matches with that line. And then the last one is firework matcher is equals to firework pattern dot matcher and I want to match it with this line. So the matchmaker matches this pattern with this line and see if they belong together. Just like Mariah Carey once saying that we belong together. I think it's here. Yeah, that song. So it's trying to find matchmakers here, right? We're trying to it's using the matchmaker to find matches. So let's find the matches. Let's check which one matched, right? So let's look at all the lines that match or which couples have matched. So we simply do if statements. We used our matcher to see. So if I indeed found the firework display line, I use the firework display matcher and call the the method, which returns true or false to check if it did match. If it did match or it matches, then I know definitely I found a firework display. I found a firework display, right? That's what it means. And then I check for other matches, right? So take matcher dot matches, and then last one is take matcher dot matches, and then we're almost done. So we're actually almost done with the solution. We just have to use it in the inside main.java. Excuse me. So let's see. So we need to, if it's a firework display, right? We need to instantiate a firework display. So what I'm going to do is, since this is going to cause issues, so I'm just going to initialize them to null. For now, that's fine. So set them to null. Firework match. Oh, I didn't use firework match. Firework match. That means I found the firework. So I'm going to use firework display instance obj display. So I need to instantiate it because I found the firework. Let's say let's only look at firework display for now, right? So let's assume I found the firework display. So if I look at my file, okay, I keep closing it. I shouldn't close it. If I look at my file or my example file, if I found the firework display, right, which is, for example, this, how many values does it have or how many strings? It is 1, 2, 3. So I expect to get 3 things. So there's a class which is very, very useful, which is called the string tokenizer class. So tokens, it views everything as a token because anything that's surrounded by a white space character, it calls it a token. So you see this string is surrounded, it is next to it is a white space character, which is a tab. So it classifies to be it does classify it does we can classify it as a token because it's surrounded by white space characters. So this will be one token. From here to there is another token. From here to there is another token. So I'm going to go into my code and create what I call a string tokenizer, right? So string tokenizer, it divides, we use this class to tokenize, meaning to split up our line into tokens. So what do I mean by that? So let me copy this. So remember what the question says. It says that everything is separated by a tab, right? So I can paste this, right? I paste it. Then I can tokenize and tell my string tokenizer class that create a new string tokenizer, and the delimiter. When you create a new string tokenizer, you pass in that line that you want to tokenize, followed by the stopping point or a delimiter. So a delim or delimiter is basically like a stopping point when you're trying to divide your string into multiple strings. So the delimiter here is a tab, which means that the moment it sees the tab, it should stop. And the final result, it excludes the white space or the delimiter. It doesn't include the delimiter. So that's why I call the delimiter the stopping point. So if I was to tell Java that create a new string, create a new string tokenizer and use the the tabs as delimiters. So it's going to read and read and read and read and read and read, and then it sees a tab, and then it skips. So this will be the first token. So this will be token number 1, right? And then it sees a tab here, it skips it, and then it sees, oh, there's text here. It says, oh, and then it sees a tab here, and then it stops like this. So this will be now token number 2. Token number 2. And then this will be the last token, which is token number 3. Token number 3. So I know that if I find a firework display, I expect 3 tokens. So that's very important to understand, because if you call or look for more tokens than the ones that are available, then your code is going to crash. So they'll cap your code at 40%. So that's why it's important for you to know how many times, how many tokens are there. So how do we get these tokens? We use the function called next token, just like next int, next double, right? But then this one is called next token, because remember what we talked about. Everything that's surrounded by white space characters, it's viewed or it's taken as a token, right? So when you call next token, right, it's very important how many times you call it. So when you call next token, it doesn't take any parameter, right? It just gives you back a token. So if you call it the first time, that means I'm taking in token number 1. If I call it again the second time, that means I'm extracting token number 2, right? So token number 1 will just be this value over here, right? And then token number 2 would be this value over here. Token number 2 would just be that value. And then you call it the third time, it will return the third token. So that's why I said it's important to know how many tokens you are expecting to get back. If you call it the fourth time, your code crashes, because you see that the maximum here is 3. So that's why it's also important to sit down and look at your file and see how many tokens you're expecting. Just like here, you see here in Firework, I have 4 tokens. That's what I'm expecting. So I'm expecting to call next token function 4 times. Once here, the second time here, the third time here, and then the fourth time here. And when you call next token function, I want you to pay attention here. When you call the next token function, right? Next token function returns a string. So if you're supposed to store a double, you must cast it back to a double. As you can see here, this is a double. So I have to cast it to a double. If there was an integer, I have to cast it to an integer. So how would you cast? That's the important thing. How would you cast? So to cast, right, there's this thing called wrapper classes, right? Not a rapper like those, no, not the rappers like your close friend who's trying to rap and always sending you songs. Like, listen to my new mixtape. No, we don't mean him who's trying to be a rap. We mean a rapper to rap, right, around the types, right? So we have what we call primitive types, if you still remember, or if you watched my videos. That's why it's important for you to watch everything. Because when I explain that, if you don't watch, you see how much extra time I'm wasting on the video explaining things that I already explained in another video. That's why the videos end up being 2 hours or 3 hours. The videos can be shorter if you guys if you guys what is this? Listen to what I tell you to do. If you tell you to watch the introduction to Java video, watch it. So that when you get here and I say primitive types, it clicks. You're like, oh, I know what it means. So this is the int, short, float, byte. So basically any type that you write in lower cases. You see, there's all of these types are written in lowercase. That's what we call a primitive type. Then we have reference. Reference types, right? So the reference types, it's called the reference types, right? They're called references because what they store references or addresses If you remember pointers in C++, but like enough in Java, you don't manage the pointers. You just work with the references. That's it. Then we have the wrapper classes, right? The wrapper classes are still also another form of reference types, but they have their own special category. Why? Because they are wrapper class. Basically, it's a class for each primitive type. So wrapper classes basically it's a reference type for each primitive type, right? There's wrapper classes for them. So let me make a few examples. So if you have int primitive type, its wrapper class is called integer in full, like this. And reference types, if you notice something, they always start with an uppercase letter. For example, string. You see string starts with an uppercase letter because it's a reference type, right? It stores a reference. So it's all basically it's an instance, it's an object. Primitive types is just a type, it's just the value. It's not the object. So if you want an object for each type, you need to call its wrapper class. So for what is for long, we have the long class. Then for what is this? For double, this double, just simply capitalize the letter D. And then for float, just simply capitalize the letter F and so forth, right? And then for char, it's a bit different. It's written character in full. That's the wrapper class. You write character in full. Notice the spelling and the capitalization. That's very important. So these are the wrapper classes, right? And then in each, remember this, I'm saying it's a wrapper class, meaning if you use this integer class, you're actually referring to the whole class. You're not referring to just the value. So that means I can call methods, right? So to convert from a string to a number, you actually need to use the wrapper classes. So to convert from string to a number, you need to use the wrapper class functions, right? And this is how you call them. It's simple. It starts by the word pass, like this, followed by the data type. So to pass, we call it passing or casting, another word. But in Java, they use pass. So when you're converting something to something else, we call that you are passing. You are passing it, right? So to convert to an int from a string to an int, you use pass int. Then you pass in the string here. And then to convert to a long, you use pass long. And then to a double, pass double. To a float, pass float. I think you get the idea, right? But then make sure the string that you're passing, it's something that can be, it looks like a number. So what do I mean by it looks like a number? So if it's integer that pass int, it has to be 2, not 2.4. That's a double. It's not an int. So it'd have to be a 2, or you can have something like this, 3. No, that's not how it works. Why is it how do I want you to actually picture this string that you must pass in? Think of it when it converts from a string, it does this. It's a simple operation. Let's say you're converting to an int. So 3, right? And then you call integer dot pass int, and then you pass that 3 there, right? You want to convert to an integer. What happens is that Java simply does this. It only drops the double quotes. It just removes double quotes, then stores what's in between the double quotes into the variable. So that's why what's in between the double quotes should make sense, should be actually a number. Because if you have something like this, if you have int x, and I say is equals to, I copied this, right? And I say 3. So what happens, remember I told you how it casts. It just removes the double quotes that are surrounding it. So it just simply does this. So that's why it's gonna crash. If you don't know this, you're not sure that the string is actually it's something that looks like a number. So you need to actually make sure that it looks like a number. But we are sure because we have the files. You see, we have the numbers there when we get there. So we have the number. So we are sure. So I don't have to worry about that. If you're not sure, you'd have to maybe find a way to double check or something like that. So let's see. So let's store the firework display. Remember, we talked about firework display. We're expecting to call the next token function 3 times, maximum 3 times, or exactly 3 times. Let me say exactly. We're supposed to call it exactly 3 times. You call it less than that or more than that, you don't get everything. When you call more, it's gonna crash. When you call it less than 3, then it's gonna work, but then you won't have everything. But it's still, oh no, it'll still crash. Yeah, it'll still crash. So don't take those chances. So let's create the variables to store everything. So in our practical, if you go to firework display, we have a firework display ID. So that's the first thing. So I'm gonna say that's an ID. Why am I saying ID? Because I don't want to write it in this way. See how long this word is? Do you see how long this is? That's unnecessary. So I'm gonna say ID is equals to what? The string tokenizer. But before we use the tokenizer, we need to instantiate it. So tokens is equals to new string tokenizer. And then it takes in two things, the line or the string that you're trying to tokenize, followed by something called a delim or delimiter, or basically what separates the tokens, what divides them. It's a tab. So I would have to put in a string and put in \t, right? Like this for a tab. But then this is not gonna work. Let me see. Will it work? I'm not sure if you have to do it like this or like that. We'll see when you get there. But it's everything is separated by a tab, right? So I'm gonna put in the tab like this. So the tab will just be a delimiter or a stopping point. So basically when it sees the tab, it stops. It stops extracting. So where is that example? Yeah, so it stops extracting. If it stops at 6, because after 6 there's a tab. So it stops there, then it counts that one thing as the one token. So that's very important to understand. Then, like, remember what I talked about? We call the next token function, which is part of the string tokenizer class. So we have a string tokenizer instance that we can call the functions on. I've called it tokens because it stores my tokens. So next token, I've called it the first time, right? When I call it the first time, remember what I talked about. If it's the first time, we expect it to be the ID. If we call it a second time, we know that second token is going to be this ode to joy thingy, which is what? The firework display names, right? So I'm just going to call it string names to keep my work simple. Tokens dot next token. And then the last thing is going to be the firework display themes, right? So it's the themes. So string themes. So lucky enough for firework display, all of them are strings. So I can leave it as it is. I can just call next token because I expect the ID to be a string. I expect the names to be a string. I expect the themes to be a string, right? Then once I'm here, I can instantiate the firework display. Where's the firework display? OBJ display. I need to instantiate it because now I have all the information. So now I need to go to my additional files. Remember the jar file that I've added to BuildPath. To find it, you click on reference libraries. Then you expand that jar file. Then you expand the package. Then you expand the class you're looking for. So I'm looking for firework display. So you see, it has a constructor here. You see, it has a constructor here that takes in 3 things, right? The string, and the pyrotechnician. So we're not sure what exactly it takes in. So let's see how we can set all of these things, right? So how I'm going to do it, right? You could, okay, you need to instantiate it. So what I'm going to do is I'm going to instantiate it using the parameterless constructor because as you can see in the information here, I have a parameterless constructor. I also have a parameterized one. But I cannot use the parameterized one because it needs me to have a pyrotechnician existing first, of which we haven't created that instance yet. So we just use the parameterless constructor to instantiate it. Then we use the setters to update the specific things we want to update. So that's the approach I'm choosing to make my work easier. So I'm going to leave it open because I need to know what are the names of the methods. So let's instantiate the firework display. So I called it obj display, new firework display. I want the parameterless constructor, right? Then I call the mutators or my setters and set all these things one by one. So I'm going to say obj display dot set id, or it's called set display id, and then obj display dot set name, which sets the name, and then obj display dot set display theme, which sets the theme. And then I'm done. I've handled the firework display. I've stored it. It's done. Now I need to move on to the next thing. So I'm going to move on to tech pyrotechnician, right? So that means I'll have to instantiate a pyrotechnician. So I'm gonna expand here and go to pyrotechnician class and see. So I also, you see, for pyrotechnician, I also have a parameterless constructor, right? And the only thing that I'm able to set for pyrotechnician is the phone number. So I'm unable to set the name. I don't see set name here. Yeah, I don't see it. Oh, format full name. Oh, but then it's private. You see, how do I know it's private? There's a red there next to it, meaning it's private. If it's green, it's public. So that means I can only access the name. So that means I need to pass the name via the constructor. But how will I know the constructor? Sometimes you can try and double click. You see, I've double clicked so that I see the code. If you don't double click, you won't know how to, in what order to pass the names or the parameters. Or I need to pass in the first name, the last name, and the phone number. So now I know. So I can just close this. And then now I know in what order I need to pass the things. And then I need to tokenize again because this is a different case. So you need to keep on tokenizing for every time it matches, so that the string tokenizer is updated continuously. So after tokenizing, I need to get the 3 tokens. I don't know. I think it's 3 also no, it's 2. Yeah. So you need to be very careful, right? You need to be very careful with how many tokens you're calling or how many tokens you're expecting. So there's a tab in between here. So there's only 2 tokens, the full name and the phone number. And remember, the full name, they expect you to pass in only the first name and the last name. How do we divide that? There's this hyphen over here. We're going to use that as a delimiter to separate them. But then before I do that, let me get the full name. So full name is tokens.next token, next token, right? And then the second thing is the phone number. So phone number is equals to tokens.next token. And then before I instantiate a pyrotechnician, remember what we talked about, that pyrotechnician, technician, I'll just call it technician, yeah. Excuse me. So remember what we talked about. Oh, it's a capital T, if I'm not mistaken. So let's see, let's try again. Yeah, it was a capital T. So I did import it. So now we need to instantiate. So remember, when you call the constructor for the pyrotechnician, it expects you to pass the full name separated. So I need to split it, right? There's a function which is very useful inside Java called the split method. It splits based on a specific delimiter, which is part of the string class. And we have a delimiter or something that separates the 2 tokens. We have a hyphen. It's up to you. You can even use a string tokenizer. That's literally up to you, but that's too much work. We have a split method. There's another approach, which is the split method. So I'm going to use that one. It returns an array of strings after splitting, right? Because you're going to have more than one string. Remember, I'm splitting it up. I'm dividing it into multiple tokens. Yeah, I'm just dividing it into multiple tokens. So I'm going to have names. I'm going to call it names to keep it simple. Is equals to, what do I want to split? I want to split the full name. So full name dot split, I call the split method. And you see that it expects me to pass a regular expression. In this case, the regular expression is simple. It's just a hyphen. So hyphen like this. And then it's going to split it up into John at index 0 and Doe at index 1 because it's an array of strings. And remember, strings in Java or in programming in general, they are 0 indexed. So I can now instantiate my pyrotechnician. So new pyrotechnician. Remember the order, the constructor that expects you to pass these things is first the first name, which is at index 0 in our array. So I'm going to call names at index 0, right? That's the first name. And then comma, the last name is at index 1. So it's going to be names. It's going to be names at index 1. That'll be the last name. And then last but not least, phone number. And then done. I've instantiated my pyrotechnician. But remember, the pyrotechnician needs to be, it's actually part of the firework display. So that's why it's important to understand the code you're given. So you see my firework display, if you go in there, you see it stores the lead, the technician, and it also keeps track of all the fireworks. So that means everything that I'm reading, I need to add it to my firework display instance. And like I said, we have mutators for that. I have set lead technician function, which sets the technician. I also have a firework method to add each firework. So you need to understand the code you're given. That's why they gave you the code so that you read and understand which methods to call and things like that. So that means I need to say obj display dot set pyro. No, I think it's set technician, set lead technician, right? And then I pass in my technician instance, which is this one over here. And then done. Then now the last thing that's left is to read the fireworks. So save, and then now we're left with fireworks. And then we're done with the, well, we're okay, we're almost done with the practical. We just need to do our main. If you, I think if you look at the marks right now, we are like a distinction now, I think. So let me quickly handle this. So I think right now the marks are like a distinction. Let me calculate. So let's look. So we have the fire handler class, right? So declare an instance of display. That's 2 marks. We did that. Close. To open the file, you see, there's 2 marks. We already have that. Regular expressions also has 5 marks. All 3 of them. If we get all 3 right, you get 5 marks, and we did get all them right. Even checking, you see those if statements to check if it matches, it also has marks. To create a firework display instance also has marks. So we are cruising nicely. So we are almost, so basically we have everything except these 10 marks because I haven't done my main.java or my main class. So this would be, I don't know, how much is the total? Okay, they didn't put, where's the total? I don't want to calculate. I'm too lazy for that. I think it's at the beginning. Yeah, 95. So minus 10. So basically we are sitting at 85 out of 95 right now. So yeah, so if you can do majority of the work and then submit even without doing the main, but then they need to see, I think, yeah, to just attempt to do the main. The main is the easy part. So let's do the firework part. Remember, we're still tokenizing. For the firework, I expect 4 tokens. But then for the firework, it becomes a bit interesting because we need to cast, we need to pass. Remember, we talked about passing or converting from a string to the right type. So we need to pass. For enums, the way you pass, the enums don't have the pass method. Instead of pass, you call the function called value of. So that's the only difference. So you put in the name of the enum. So name of enum dot value of. Then you pass in the string here, whatever that's the string. The string needs to be something that's equivalent to this enum, or it's one of the values of this enum. So this is how you'd cast from a string to an enum type. So that's the only new thing that we're going to introduce there. So we have what? So I need to know the names or the actual things. Then what are they called? So we have firework ID. So I'm gonna say string ID is equals to tokens dot next token, and the ID is a string, so I don't have to cast or pass. I pass the value. I just leave it as it is. And then the next thing is also a string, if I'm not mistaken. So it's the firework names, right? Let me see. Where's the file? Yeah, firework names. Okay, there it is. So firework names, that's number two. So I'm just gonna call it names again. Tokens dot next token. They're also string, it's also a string, so that's fine. You might ask yourself, why am I using the same variables? Well, there's this thing called scope. So this names for tag measure, it's declared within this curly braces, so it only exists here. So that's why it's not complaining when I also declare it again down there. So scope is very important to understand. So string names, and then the other thing we need to declare now that I know for sure, it's a number. Yeah, the next thing is a number. It's the fuse length. So I'm gonna call it it's a double. So double fuse length is equals to tokens. Remember, we need to pass this thing tokens dot next token. So this whole thing, calling this function returns a string. But remember, the formula is that I need to use the wrapper class. So double dot pass double. Then I pass in the string within the is a parameter that I want to cast to a double, which is the call to the function to the instance tokens. So that's why I'm pasting this whole thing, because this whole thing returns a double, right? Which is what we've read from the file, which is this 1.2. So basically, in other words, it's like I'm saying 1.2 here, but as a string, remember? And then it casts it to a double, and then it stores it in here. So that's, in other words, what it's doing. So don't be confused. Don't look at it and see that it looks like it's too complicated. It's really not too complicated. Then we're gonna deal with the enums now, right? Remember with enum, we talked about that you use value of. It's still sort of like the syntax is similar here, like this, but instead of pass double, pass int, or pass float, use value of function. So let's look at what we need to store. What is it called? It's the color. So I'm gonna say color. I'm just gonna call it color. So, and it's of type E color. So E color, color, like this. And then I'm gonna import my color, right? So there's the color. So there's the type. So this is the name of the enum. So that's the name I'm gonna use. So come on, is equals to that enum name, the name of the enum, dot value of, then you pass in the string that you want to cast, which is the next token. So tokens dot next token. So this would convert this token or that string to an E color. So now we have everything that we need to create a firework instance. So I'm going to say firework, right? And then just firework. And then I need to import it. So I'm just going to leave it like that first, then import. And then let's instantiate it, right? So let's instantiate it. So it's equals to new firework, firework, like this. Let's see how the constructor works. In what order we passing the information. So you have, why this guy doesn't mute? Hey, because now it's disturbing everyone who's currently paying attention now. And now I'm wasting time on small things that you guys should be muting. Firework, let me double click on that. So there's firework, minimize. So it expects in this order: a firework ID, firework name, the fuse length, and the color. So it has to be in that order, which is the exact order I read it in. Because if you check, it's the firework ID, firework name, firework fuse length, and the color. So it's the exact same order in which I read from the file. So I don't have to think about it too much. So I need to pass in the ID, the name, the fuse length, and then the color. And then done. I've instantiated the firework. But remember what I told you about, what I talked about. The firework and the pyrotechnician are part of the firework display class. So you need to add them. When you create the instance, add it to the firework display class. So there's the firework display class. You see, it should be as okay. Let's see. Yeah, there's the add firework method. So you see, I'm gonna double click on it. So you see, there's the add firework. So it expects you to pass in a firework. So I'm going to add that firework using that function to my firework display class. So I've called it obj display dot add firework and add this new firework that I've instantiated. And remember, it's inside a while loop. So it will keep on repeating this as long as there's a next line to read. And then I'm done. That's the whole solution. Now we just need to do our main.java, use it, and then we're going to see output. So let me create my class. Remember the main class or the main class, it shouldn't be inside any package. So I'm going to create my class. Make sure you remove package in the package here at the top. It shouldn't be, the package part at the top should be empty. Then I'm going to say main. It needs to have a main method, generate comments, finish. Always put your main inside the default package. Basically, don't put it inside any package, the main class. So there's my class, my main function. So let me create an instance of the firework display. So display handler, the display handler. So before I do that, I need to store the file name, right? So string file name is equals to, then I need to remember the name of the file, right? It's inside a specific folder. So you need to specify or tell Java to go within that folder first, then look for this file. So I'm going to tell, you see that every file that I'm supposed to read is inside data folder. So I need to go do this and say, go to the data folder. You can use backslash, right? But then remember, if you use backslash, you must escape the backslash, right? You can't write it as once. You need to escape it. So if you read the textbook, it advised you guys to use /, because when you use a /, it can be applied on any operating system. If you just use the backslash, it only works on Windows. So that means you're limiting your code to only work on Windows. So you're going to use the /. So /, and then you choose any name except for the data files. You see the data files, it means that there's something that's incorrect. So it won't read everything. So let's start with the clean one. So clean one or clean_1.txt, right? That's the file name, which is inside the data folder. So this means, right, what this file name means, it means go to the data folder, / means go inside of the data folder. You will find this file. So I have to write it like that, or else it won't find the file. Then now once it has found the file, I can read from my file. And remember the function that reads from the file, it returns a firework display instance. So I need to create that instance to store the answer. So firework display, I'm just going to say display is equals to, the class name is display handler, display file handler. Remember, I used the static method, so I don't have to create an instance of display file handler. I just use the name of the class followed by the name of the function followed by the parameters, because I've made it static. If I didn't, I would have to say new display file handler. So I don't want that unnecessary work. So I need to import firework display. So import that. Then done. Let's see if there's a toString function. So I'm going to go to referenced libraries, open my package, and then see if I can see a display function here. Is there display? Yeah, print display. You see, there's the function. So I need to call this function. That's why it's important to double click and check the code you are given. So you see the print display, it's a function that displays everything. So you see how easy the main is after you've done. So you just simply say display dot print display. It's called print display. Then done. So this is what your main should look like. So don't guys don't complain about I couldn't do my main. You couldn't write 3 lines to get those 10 marks. So it's important to attempt everything. So let's run it and see if it works. Come on. Okay, quickly closed. Yeah, so it works. So obviously for you guys, maybe it might not work first try, but for me, I have experience. So you see everything is stored. Bouncing Betty, there's this 1.0.7 yellow, which is exactly what's inside the file. If you look at the file, you see there's Bouncing Betty 2, there's 0.177, there's yellow, there's ode to joy, there's New Year's Eve. Everything that I've read that's in the file, I've read it perfectly. So you see, there's the output. And then that's pretty much how you do the practical. So it might be actually very similar. Yeah, you might actually have a very similar practical today. That's if it's in session. If it's not, then I'm not sure, but I think it should be very similar. Yeah, I think it should be very similar. So that's pretty much all you had to do. So let me stop recording so that I can take questions now, if you guys have any questions. So let me stop recording. So do you guys have any questions?